Type of dams. What is a dam? What are the main components of the dam? What are the type of dams? Today we are going to discuss about dam types, and each type will be discussed in detail. I am Prasad from Structural Guide. You are welcome to the Structural Guide YouTube channel. Please subscribe our YouTube channel. You may get the notification on new videos. What is a dam? Dam is a structure built to retain the water. It could be a single structure or combination of several structures. A large dam used for the drinking water, irrigation and power supply. A dam contains structures such as spillways, outer structures and embedded structures. And there are many other structures connected with the dam construction. Main component of the dams and what are the main type of the dams. Let's discuss first component of the dam. Spillway, which is a part of the dam structure. Guide wall, mostly it's connect with the dam structure. Diversion tunnels and plugs. These are construct for the diversion purposes or the construction purposes of the dam. Even after the construction, sometimes these tunnels may be remain as it is. Coffer dams. Coffer dams are mainly constructed to support the send the water to the different path and block the water for facilitating the construction of the dam. Bottom outlet. They are mostly used as the most lowest outlet in the dam structure. They may be used for different purposes. Maybe irrigation, maybe water supply, maybe any other purpose. Transfer canals also same. They may be used for sending water for any other area, maybe supply to feed any other dam, maybe any other canal. This transfer canal may be used. Irrigation water supplies part of in the dam. Maybe it may be construct for the power and irrigation, so part of the water will be sent to these outlets remain connected with the dam. Power intakes, power houses may be connected with the dams. Grout curtains to avoid water seepage below the ground, below the dam body, we construct the grout curtains. Inspection galleries. Inside the dam, within the dam, you may construct the inspection galleries to inspect the condition of the dam. After the construction of the dam, you may need to examine the condition of the dam because it's a heavy structure, very large structure. There may be deflections, there may be movements, there may be water pressure developments, different manner. To monitor all those or to connect all the data coming from the instrumentation, etc., you may have a inspection gallery. Saddle dams. In a large dam, when you construct a large dam, there may be very large area may be filled with the water. So you may have to block some other areas to avoid the water movement. There may be upper level, there may be some water path when the water is filled. So in such case, we may build saddle dams, avoid that water movement when the dams get filled. Type of dams. Mainly there are 5 types. There are many more types you can categorize the dams. I have listed 5 types here. Today we are going to discuss about these 5 types. Earth dams, rockfill dams, arch dams, buttress dams and hydraulic fill dams. Earth dam. What is earth dam? Earth dam is also called as a embankment dam. Use impervious material such as clay to construct earth dams. Dam coils consist of impervious layer of material. This impervious material, avoid the water seepage. However, we cannot avoid the seepage completely. Drainage will be provided at the downstream to smoothly drain out the water coming from this dam. About 33% of the earth dams fail due to the excessive seepage. Therefore, seepage need to be drained out very properly, and also dam seepage need to be controlled. There are two type of earth dams: homogeneous dam and zone type dam. In this figure, you can see here this is a zone type dam. We have a different zone here, we have a different zone here, we have a different zone here. So different zones are there, not homogeneous dam. The same material is not used for this dam. So in a homogeneous dam you may use the same material, but in a zone type dam there you have a core here. The core is mostly constructed from the clay, because clay is very less permeable. Permeability is very low in the clay, so water seepage is very less. So we use clay in these type of dams to avoid the water seepage. Dam failures could be occur due to the hydraulic failures. Overtopping, erosion, and cracking could cause failure of the dam. Seepage also could cause. Piping effect may cause the failure of the dam in the seepage. Stability failures may be there in the dams. Sliding, overturning, those things could be there. And also earthquake effects may cause failure in the dams of this nature. Rockfill dams. Rockfill dams bit complicated than the other type of dam. There are many components in the rockfill dams. If we start discussing about this component first, the number one you can see here, this part is the clay core. The clay is filled with the core of the dam to avoid the seepage. Next to the clay core, you have the filter. This is filter. So smoothly water will be sent into the clay core. That is called the filter. Most of the time you have filter in the not mostly actually always you have the filter in the dams to send the water into the smoothly send the water out without eroding the clay core material. If you don't have a filter there, the clay in the dam will be washed out. Therefore, you have to have a filter there. Then you have a transition material. What's the transition? Now, dam with filled with the rock. You can see here this part filled with the rock. So, filter is very fine material. You can directly connect filter with the rock fill because it will damage clay core and the filter as well. You cannot maintain the clay core and filter shape as it is. Therefore, you have to transit from that smaller particle to larger particle. You need the transition. Therefore, we use transition here downstream. Upstream, usually you don't have a filter because water is directly contacted. So water coming this way, no need to have a filter because that way water getting into the dam. So there's no need of filter. But downstream, you need to filter to avoid the washout of the clay core. So here you have a rock fill. The most of the volume of the dam will be taken by the rock fill. When you're designing a dam, you have to consider the stability of dam. Stability against sliding, stability against seepage, overturning, then stability against earthquake loads we have to consider. So minimum factor safety maintained for each dam. So these may be depend on your specification or the design requirement you consider. So normally dams are designed for a larger lifespan, not like building structures. Building you may be designed for the 50 years, but dams at least they design for 100 years. There may be more than that, maybe it may be 120 years, maybe 150 years, maybe 200 years. That's depend on the design you do and the importance of the dams and facts you consider during the design. Arch dam. As you can see in the figure also, this is a curved dam. This is a shape is arch shape. That's why it's called arch dam. This is a concrete dam and it's have a curve in the upstream. Design so that the water pressure on the dam acts against it to straighten the dam, and that make stabilize the dam. So when you the water pressure is coming from here, it's try to straighten the dam. This is a curved dam, so it's try to straighten the dam. With that, it's make its stability against the dam. So there may be different type of arch dams: constant radius arch dams, variable radius arch dams, double curved arch dam. Those are the most common type of arch dams you find in the world. Design life, as we discussed previously also, design life may be 100 years, it may be 120, maybe 150. It's depend on the design or the importance you consider in the dam design. Buttress dams. It's a kind of a gravity dam that provides stability its own weight. The dam support on the buttress or similar structures that are placed at a regular spacing. Instead of buttress, there may be different frame structures may be used to support the dam front face. With the stress of the dam body, with that actually the stress if you have the buttress, with that you can reduce as they are placed regularly, you can reduce the stress on the dam body. When you're doing the designs of these dams, you have to pay the attention on the durability of the structure. This is a concrete structure, there may be deteriorations, therefore you have to consider these things when you're designing of these type of dams. Mainly there are three types of buttress dams: rigid buttress dams, deck slab buttress dams, bulk head buttress dams. These three types also available in the world as a buttress dams. Hydraulic fill dams. These also embankment type dams. They act as a gravity dam. May be considered as a earth dam also. Depending on the material availability of the dam body, we can classify these dams as earth dams. Material transport from the burrow pits and the placement in the dam location are done by the water. Material mixed with the water forming a sludge, and they are transferred to the dam body through the pipes to deposit in the dam body. So this is also a kind of a dam. So I think we discussed about different type of dams and what are the main type of dam construction materials, how do they construct, what is the dam, why we need the dams, what are the main component of the dams. So let's meet again from new video. Thank you very much.